So let's take our factoring flowchart back out. And remember, starting at the top, the first thing we're supposed to do is see if the thing has a GCF. If it does, factor it out. If it doesn't, we're going to move on to how many terms does the thing have? Does it have 2? In other words, is it a binomial? Am I going to factor it as a difference of 2 squares or the sum or difference of 2 cubes? Okay, or did it have 4 or more terms where I could do it by grouping? Okay, so finally, the thing that's left over for this lesson is if it has 3 terms, if it's a trinomial. And you can see that it breaks down into 3 categories. We've got perfect square trinomial, yes or no. And this one is going to be the easiest one because it's based on a pattern that we've seen before. Okay. The next one is, well, does it have a leading coefficient of 1 if it's not a perfect square trinomial? And then the last one is this thing that we're going to call the AC method when it does not have the leading coefficient of 1 and is not a perfect square. Okay, so we're going to start off with the easiest one in just a second, being perfect square trinomials. So our objective here, being able to factor a trinomial. In this picture, which I think is pretty cute, you've got 3 girls that are completely fawning over this picture in the background, of course, of the Beatles. And they're triplets, so they're like 3 girls that all have something kind of in common, but their outfits are just kind of variations on each other. So it's kind of like a trinomial here. Okay, so again, we're going to start with the easiest one, a perfect square trinomial. And we've seen these things before, so let's go ahead and start with one, x plus 3 squared, and let's square it out. Remember, that's not just x squared plus 3 squared. No. So whenever we go to FOIL it out, write it times itself, and the middle term turns out to be the same, so it adds up, it doubles up. And so I have x squared plus 6x plus 9. Okay, so remember what the pattern was, like if the shortcut, if I wanted to get straight to it, I would take the first term and I would square it. I would take the last term and I would square it and I'd get 9. The middle term is just 2 times the product of x times 3. The reason why it's 2 times is because that 3x, whenever I FOIL it out, happens twice. Okay, so going backwards now, again, what I would have if I were trying to factor is I would be given x squared plus 6x plus 9, right? And I would have to factor it. I would recognize it as a perfect square and I would write it as x plus 3. How do I get that? Well, the x is just the square root of the first term. And the 3 is just the square root of the last term. And that's it. Okay? So now it's not quite that simple though, because we have to check to make sure that the middle term matches up. Okay? That the middle term is 2 times, say, the last one times the first one. Okay. So on your flow chart you have the 2 kinds, or the 2 variations of perfect square trinomials, if the middle term is positive or if it's negative, and we've seen those things before, but we saw them going backwards. We were actually squaring out the binomial instead of trying to factor it. Okay, so here's how you can spot a perfect square trinomial. This is what you do. So step number 1, you're going to check to see if the first term and the last term are perfect squares. Alright, so usually the first term is something like x squared, so of course that one would be a perfect square. Okay, and then the last one, you have to know your perfect squares. Things like 1 and 4 and 9 and 25, you know, things like that. Okay, if that's the case, then step 2, you want to take the square roots of those terms. So in this case, you're going to take the square root of a squared, you're going to get a. You're going to take the square root of b squared, you're going to get b. Okay? And then, step 3, you're going to multiply those 2 together and double it and see if that matches your middle term. Right? We're going to see if that matches the middle term. Now, there is a shortcut to this if your leading coefficient is 1. Alright? So if the leading coefficient is 1, this is very, very simple. All you have to do is take the middle term, take half of it, and then square it. If that matches the last term, if it matches the last term, you know it's a perfect square trinomial. Okay? So let's practice this on a couple of these perfect square trinomials so you can see these things in action. So, problem number 1 here. X squared plus 8x plus 16, we're going to try to factor it. Well, x squared is a perfect square. 16 is also a perfect square. So look, since the leading coefficient here is 1, I'm going to take the shortcut here. I'm going to take this 8x and I'm going to take half of it, and that would be 4. Right? I'm going to take half of it. And then if I square that 4, I get 16. Therefore, it must be a perfect square trinomial, and it would factor as x plus 4 squared. Right? Okay. Or I could have done this. The square root of x squared is x. The square root of 16 is 4. 4 times x is 4x times 2 is 8x, and that matches the middle term. Okay. Now, number two, leading coefficient is not a 1, so I can't take that shortcut. Okay, so is 9x squared a perfect square? Sure it is. It's 3x if we take the square root. 16, well, just like before, sure, it's 4. Now let's check to see if the middle term matches up. I would do 3x times 4, that'd give me 12x, and then if I double it, I get 24, so it checks out. The middle term matches up. So this should factor as 3x, keep the sign that's right there in the middle, plus 4 squared. Okay, so number 3, x squared minus 2xy plus y squared. Even though the leading coefficient is 1, since all of these things are variables, that little shortcut's not necessarily going to work. Okay? So what we have to do instead is go back to the original way. Take the square root of x squared, I get x. Take the square root of y squared, I get y. Multiply them together, I get x times y. Double it, I get 2xy. And that checks out with the middle term. Except for this time it's minus. Okay? So my factor is x minus y squared. Minus because the original one had a negative middle term. Okay, there we go. So here are 4 of them for you to try, these perfect square trinomials. Go ahead and pause the video and let's see what you come up with. Alright, so here are our answers. The first one, I was able to take the shortcut. You take half of the 2, you get 1, you square the 1, it's the last term, it matches up, so it factors as z minus 1 all squared, quantity squared, minus because the middle term is minus. Okay, I could also take that same shortcut on number 2, take half of the 14, I get 7, 7 squared is 49, so it works out. And this one turns out to be x minus 7 quantity squared. Okay, so even though there's a decimal in this one, hey, it still works out. I take half of 1, I get 0.5. Square 0.5, I get 0.25. So this one also works out as a perfect square, a plus 0.5 quantity squared. Okay, you can't take the shortcut on number 4, so you just take the square root of the first term, it's xy. Take the square root of the last one, it's z. If I were to multiply those, I'd get xyz. Double it, I get 2xyz. Hey, checks out. So it factors as xy plus z quantity squared. Alright, so there is the first part of the first objective about being able to factor a trinomial if it is a perfect square trinomial. Okay.